Hi, I'm Eduardo Montalvo with Koru Technology, and in this video we will be going over several common questions that come up when working with our RedRock TMR sensors. This is the list of topics that will be covered in this video. First, we'll touch on the subject of the decoupling capacitor that is required for proper sensor operation, as well as its optimal position with respect to our RedRock TMR sensor. Then, we'll look at the effects of having external resistors connected to the sensor's pins and how these might affect things like current consumption and sensor startup. And lastly, we'll go over how some of these items might affect configurations that use multiple sensors. Let's start with a decoupling capacitor. Now, all RedRock TMR sensors require a capacitor of 1 microfarad or more placed between its VDD and ground pins. Now, this value of capacitance is required to maintain the supply voltage at the sensor's input terminals during its startup phase. And it also helps to filter out any noise that's coming in from the supply lines. Now, in addition to the capacitor value, its location with respect to the sensor is also important. Several issues, such as oscillations on the output signal, failure to detect the magnetic field, or improper sensor startup, could be caused by a decoupling capacitor that has a low value and/or has been placed too far away from the sensor. To ensure proper operation, we recommend keeping the decoupling capacitor as close as possible to the sensor package. If it can't be placed right next to the sensor, then we recommend keeping it not more than 10 millimeters away. In conjunction with this, avoid having any long traces or long leads between the capacitor and the sensor terminals. Next, let's talk about the effects of having external resistors connected to the sensor's pins. First, let's look at what happens if a pull-up resistor is placed between the output of a push-pull TMR sensor and the supply voltage, as shown below. Now, this configuration will lead to an increase in the overall current consumption of the system when the sensor's output is low. The reason for this is that a push-pull TMR sensor has two MOSFETs that connect the output pin to either VDD or ground, depending on whether the magnetic flux density present is above the sensor's operate threshold or below its release threshold. So when a magnetic field is present, the lower MOSFET turns on, and a path between VDD and ground is created through that pull-up resistor. As seen in the example below, a 10K ohm resistor would lead to a current draw of around 300 microamps from the supply lines. This is significantly larger than the average current consumption of the RedRock TMR sensor itself, which can be as low as 50 nanoamps. One scenario where this can come into play is in applications where a reed switch is replaced with a TMR sensor. When using a reed switch to detect the presence of a nearby magnet, a pull-up resistor is placed between the switch and the supply to provide a logic high or low level, depending on whether the switch is open or closed. A push-pull TMR sensor, on the other hand, is capable of producing a logic level signal on its own without the need for a pull-up resistor. Now let's talk about what happens when a resistor is placed between the supply voltage and the sensor's VDD pin. It's important to note that RedRock RR1X2 TMR sensors have an initial current draw of around 1.4 milliamps for a very short duration during their startup phase. And so depending on the value of the resistor placed between the VDD and the supply, this initial current could produce a large enough voltage drop across it that reduces the voltage at the sensor's input terminals, which would in turn prevent it from starting up properly. It is also important to keep in mind this startup current in applications that use multiple sensors powered from a single supply, such as liquid level sensing devices. Now, even though the startup current of a single sensor is relatively small at only 1.4 milliamps, applications that have a large amount of sensors turning on simultaneously might see a larger initial current pulse due to all the startup currents adding up. For this reason, it is common practice in these types of applications to power on smaller groups of sensors instead of all at the same time. And the number of sensors that can be turned on simultaneously can be determined by taking into account any current limits in the circuit and making sure that the combined startup current is below that limit. Also, as with the example on the previous slide, having a resistor between the voltage supply and the VDD pin of the sensors can cause issues with sensor startup. Now, these are just a handful of things to keep in mind when working with RedRock TMR sensors. If you have any additional questions about these or any other items, please feel free to contact us at any of the email addresses shown here. Thank you very much for your attention and for your interest in Koto's RedRock TMR sensors. We look forward to helping you out with your application needs. Thank you.